Hello everybody and welcome to section 3. Here we're going to talk about the motion of the ocean. Let's get started. So, water moves. We all know this, I hope. The motion of water, especially where it touches land, helps to shape the geology of the coasts. Right? And we're talking about currents and tides, as well as waves and sea level rise generally. Be a little bit more on this in the assignment, so we're not going to talk about it as much here. Currents, right? First one on our list here, currents. What are we talking about? So we have these circulation patterns in the ocean which are fairly consistent and fairly stable over time. And you see a map, this will make a whole lot more sense. I promise, just stick with me here. The fastest of these currents is the Gulf Stream, the northern Atlantic, carrying water from the equator up, from the Bahamas, really, up through the east part of the United States and all the way to Europe. It moves fairly fast as far as currents go, about 4.5 miles an hour. Again, this does not sound fast, but if you have been in a part of the ocean moving at 5 miles an hour, you know this is really fast. This is caused by wind, density differences, and water masses, which might be caused by differences in temperature or salinity. So, low temperature is going to be colder, it's denser than warmer water. If it has more salt in it, it's also going to be a little bit denser too. You have differences in gravity in different areas, as well as events like earthquakes and storms. So, finally, these are controlled by, constrained by shapes of continents. You can't have a current that goes through the continent. So the continent shape is like your rigid block, and the oceans move, but they can never go through or over the blocks. You'll see the map, this will make a lot more sense. Right? Most of these follow a similar pattern, broadly speaking. Right? We start with the equator. The equator is warm, easy to remember that, all know that. It starts here, and northern hemisphere rotates clockwise for these, comes up, it's warm, and it carries that warm water up here. And then once it's up here, it gets a little bit colder water added, until it gets cooled off. And actually down here, west coast here, if you've ever been on the water at San Diego, it is cold year-round. It's a cold water stream coming down here, all the way down to the equator where it began. You see a similar pattern over on the North Atlantic Ocean here. So we start with the equator, warm stuff comes up, until it gets colder, and then cools down as it comes back to the equator. Southern hemisphere, we have somewhat of the opposite pattern, going counterclockwise here, counterclockwise here. It's clockwise in the northern hemisphere. So this will be something we talk about in the future. So there's just going to be a little bit of foreshadowing. Deserts, yeah, these are the latitudes where you see deserts, right? Desert here, desert here, desert here, desert here, desert here. There's a reason for this. We'll have that more in the next unit. Talk about one current in particular, maybe everybody's favorite current, the East Australian Current. Right? If you've seen Finding Nemo, you've heard of this, right? They start out in the Great Barrier Reef at the beginning, and they jump on the East Australian Current with the turtle buddies and ride it all the way down here to Sydney. Right? It's a pretty big current. Just making an example of this, try to make it relatable. So this is what we're talking about. We're talking about currents. We have surface currents, we have deep ocean currents that are sort of two different layers to the systems, sometimes moving even in different directions from another. At the surface currents all the way down to about 200 meters, so 600-ish feet below the surface. And we have the deep ocean currents, everything is at least 1,000 feet, or about 300 meters below the ocean surface. These tend to regulate Earth's climate all over the place. You have certain places which are warmer than you might think, places that are cooler than you might think. A lot of the reason for that has to do with ocean currents carrying warmer or colder water, especially in cases where you have heat, which is coming from warm tropical areas to your colder areas near the poles. We'll do this in a bit. These surface and deeper currents are connected by what's called the Great Ocean Conveyor Belt, a process called thermohaline circulation. So thermo, temperature, thermo means temperature. Haline means, in this case, salt, right? Talk about halines. Haline means salt, so we have temperature, salt, circulation. Those are the two biggest factors we're talking about here. So you imagine we're coming up here, right? Have our warm stuff at the equator, travels up, and then once it hits here, it's got all this fresh water coming in from melting of solid ice in Greenland, yeah? And this causes two things. It causes the temperature to drop, making it denser, and it causes the salinity to decrease because we've added fresh water to the system. And so it sinks, goes down. It's actually traveling beneath this warmer one here. Beneath, all the way up until it gets back to the equator. Then it heats up again and rises up, comes back to the top. So we're going to talk about one particular part of the ocean current system in particular. Talk about the Gulf Stream. So this is very, very important. We're talking about the Gulf Stream system that works like a heat conveyor belt, moving warmer surface water from tropical areas, like the Bahamas, up north, and then sending colder water back down south. Now, this is something which is changing within our lifetimes. So, things changing on like the 100-year scale. Much, much faster than anything we're talking about with plate tectonics, other parts of geology. This is something which is weaker now than at any point in the last 1,600 years. This is a fact. It is getting slower. Slower in this case means weaker, transferring less heat to places that are at higher latitudes, like further away from the equator. This slowdown, this is also a fact, is linked to man-made climate change as a result of collective human actions putting greenhouse gases into the atmosphere. So, we have warm water starting in the Bahamas. This is our Gulf Stream. We're talking about Gulf Stream here. Travels up along the east coast, all the way up, and heats up Europe. Everything up here before it sinks. So, places like England, Scotland, Ireland, Wales, all of this, all of Western Europe. This is all at the same latitude, right? Just as far away from the equator, as far north of the equator as everything in Canada. But the weather there is not like the Canadian weather. And the reason why, large part, is this Gulf Stream bringing warm water. This thing goes away, the weather in England is going to be exactly like it is in Canada. Yeah. If you look at a heat map, this is pronounced. Like somebody shows you this map and you knew nothing about currents, you didn't take this class, you knew nothing about what's going on, you would still look at this and point and say, hey, that's kind of a big thing going on in the middle here with a red. What is this about? Right. So next part of this section, the section within the section, we're going to talk about tides. I'm talking about twice daily rise and fall of sea level. Tidal range can be anywhere from like 6 feet to 10 feet between high and low tide to even up to like 53.5 feet. So 50 plus feet of vertical distance. Right? These are vertical measurements here for sea level between the high and low tide. Right? So this is talking about here, we have Fundy, that's like southeast, eastern Canada here, just northeast of Maine, like on the east coast. Right? These are our spring tidal ranges here. Spring tide is maximum tides. We could do that in a bit. We have 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16 all the way up here. At it, going into the Bay of Fundy. And pictures, this is what it looks like. So here, walk around, plan a hike, do some stuff, low tide, high tide, not so much bring a boat, yeah. People have boats here, this is what it looks like at low tide, this is what it looks like at high tide. This happens twice a day, every day. You really got to be in tune with these things, got to know the timings, otherwise, show up to use your boat, and it looks like this. So what is causing these tides? Tides are caused by the gravitational pull of things like the sun and the moon, principally big celestial bodies, which are distorting the shape of the entire Earth and all the water on it. And the diagram here is maybe not the best in some ways, but the sun is much further away, of course. than it is in this diagram, but that is not important. What's important is the point here, which is we have spring tides, we have the combined pull of the sun and the moon, and the moon is pulling a lot harder than the sun, not because it's bigger, but because it is so much closer. The sun is much bigger, but obviously much further away. So the amount that it pulls is less, even though it is not clear how far away the sun is in this particular diagram. We have spring tides with the highest highs and the lowest lows, and neap tides with the highest lows and the lowest highs. So spring tide occurs whenever the sun and the moon are pulling in the same direction, stacked on top of one another. Neap tide is when these two are perpendicular, pulling in different directions from one another. So in more detail, spring tide, we have our high highs and our low lows, extremes on both sides. Nothing to do with spring, the season. It's more from this term of the tide springing forth, if that helps you to remember it at all. So it will be twice each lunar month. Lunar month is 28 days. It can occur on the full moon and the new moon. Neap tides are your lowest highs, your highest lows. Stick with me. Where the word neeps come from, I do not know. This could be a pack-back question. Maybe ask there. I don't know. Don't ask me. It occurs about 7 days after the spring tide. It's going to be your first and third quarter moon, so times when the moon looks half full. Yeah, first quarter, third quarter moon for your neap tides. New moon, full moon are going to be your spring tides. And actually, we're going to go ahead and pause here, running a little bit more on time. We'll finish the rest of the section in the following video. Come back.